Hi, I'm Naina Manori, working as Assistant Professor in the Civil Engineering Department, SVIT, Bengaluru. I'm the course coordinator for Advanced Surveying. We'll discuss Module 2, that is tachyometry. A tachyometer was set up at a station A and the readings on a vertically held staff at B was 2.255, 2.605 and 2.955 meter. The line of sight being at an inclination of plus 8 degree 24 minutes. Another observation on the vertically held staff at benchmark gave the readings 1.640, 1.920 and 2.200 meter. The inclination of line of sight being plus 1 degree 6 minutes. Calculate the horizontal distance between A and B and the elevation of B if RL of benchmark is 418.685 meter. The constants of the instruments were 100 and 0.3. Read out the problem carefully. You can observe here a tachyometer was set up at station A and simultaneously two observations were taken at the station B as well as on the benchmark, and the respective stadia air readings they have given and the respective angle of inclination they have given. Okay, you can observe in this problem plus indicate that is angle of elevation. If in the problem if they have mentioned that is negative, okay, that is minus 1 degree 6 minutes for example, it indicates what? Negative sign indicates angle of depression. You need to calculate horizontal distance as well as the elevation of the station, that is B, and if the RL of benchmark they have given it as 418.685. Okay, first write down the data. What are all the datas they have given? Okay, before that I will write down that figure for understanding the purpose. Okay, what they have said, a tachyometer was set up at a station A. Okay, I will call this as station A where the instrument it is set up. Okay, this is what? This is the ground. Okay, this is the tachyometer station. They are mentioned in the problem, that is station A. Okay, and the readings was taken on vertically held staff at B. Okay, the staff was held at station B. You can observe that is the angle they have given, that is angle of inclination, it is plus 8 degree 24 minutes. Means what? It is angle of elevation, means the telescope it is raised upward direction. Okay, write on the B station. Compared to tachyometer A station, the B station should be in the higher position. Okay, this is what? Station B, and the observations were taken and the respective staff readings are 2.255, 2.605 and 2.955. Okay, the always first reading will be the upper stadia, second reading will be the middle stadia reading, and the third one will be the lower stadia reading. Okay, angle of elevation. Okay, draw the three rays, middle air. The telescope it is raised upward direction. Okay, draw the three stadia hairs. Okay, rays. This is what? Upper stadia, middle stadia. This is lower stadia. Okay, these are all the observations they have taken, and show it here. The line of sight of the station. Okay, okay, you can observe here. This is the angle of elevation, that is 8 degree 24 minutes. Okay, the distance between A and B station, call it as D. You need to calculate it. that is D, distance between the station A as well as B. You need to calculate it. Okay. Next, from the line of sight to the middle stadia air, okay, that height you call it as what? Small h. Small h. It is nothing but what? Middle stadia air reading. Then from the middle stadia air to this line of sight of the instrument, that height you call it as capital V. That is what your vertical component. Okay. Sorry, here h is what? Middle air reading. That is what? From the middle air to the ground, not the line of sight. Make a correction here. Okay. From the middle stadia to the ground, that height you call it as what? H. Then from the line of sight to the middle air, that you call it as what? Vertical component. Okay. Similarly, another observations were taken on the benchmark and the readings they have given. The first reading is what? Upper, middle, and this is lower. You can observe that is angle of inclination, it is plus 1 degree 6 minutes. It is also angle of elevation, plus indicate elevation. Okay. Write down the ground profile. Okay. This is what? That is the benchmark. Okay. Extend this line of sight of the tachyometer. Okay. And the observations they have taken. Write down the 3 stadia rays: lower, middle, and the upper. Okay. Then the difference of upper and lower will be your staff intercept. It is denoted by S. You can observe here difference of what? 2 stadia readings, that is upper and lower. It is denoted by staff intercept S. Okay. The benchmark RL they have given, that is 418.685 meter. Okay. 418.685 meter. Okay. Same way here also. See, from the ground to this middle air, that height you call it as what? The first observation which is taken on the benchmark. I am going to denote it all the observation. That is the first observation. I will give it as H1. Similarly, this is the second observation taken on the staff station, that is B. I will give it as this as H2 and this is V2. This is second observation. This is as S2. This is the first observation which is taken on the benchmark. Okay. Next is what? From the line of sight to the middle air, middle stadia air. Okay. That height you call it as what? That is capital V. It is what? That is V1. Okay. Then the difference of what? Upper and lower, that is what your staff intercept, that is S1. Your aim is to calculate what? That is RL of B station. This RL point you need to calculate it, which I have shown it here circle, right? This point RL, and you need to calculate the distance between A as well as B. If you draw this figure, it will be easy for your further calculation. Okay. Okay. So you can observe here. Okay. From the first observation, first you calculate, that is the vertical component. Okay. Before that, write down that is H1 value. H1 is what? Middle air reading. That is the observation which is taken on the benchmark. The stadia readings were they have given. That is the middle air reading. It is what? That is 1.920. H1 is what? 1.920 meter. Okay. Then you calculate, that is the staff intercept. That is S1. It is difference of upper and lower. Okay. That is, which is higher value is subtracted. 2.200 minus 1.640. Okay. Upon simplification, like you will get it as S1 as 0.56 meter. Okay. That is the staff intercept. And this inclination is what? 1 degree 6 minutes. This is what? Theta 1 I will call it as. That is 1 degree 6 minutes. Okay. Next, RL they have given. RL of benchmark. that RL of benchmark it is 418.685 meter. Okay, now the formula to calculate the vertical component V1 it is given by, the vertical component it is given by, so you can observe when the line of sight it is inclined, it is inclined upward, whether it is inclination it is upward or downward. Only thing, if the line of sight if it is inclined, the vertical component it is given by, that is what, Ks sine 2 theta divided by 2 plus C into sine theta. Whether angle of elevation or depression, whatever it may be. If the line of sight if it is inclined, the vertical component it is calculated by using this equation, that is K into S into sine 2 theta divided by 2 plus C into sine theta. Here you are calculating, that is the first observation which is taken on the benchmark. That's why the staff intercept it is S1 and theta will be theta 1. Substitute the value and calculate V1. You know that K is 100, they are given in the problem. And the staff intercept S1 it is what, 0.56 into sine of, theta 1 it is 8 degree, that is theta 1, right, that is 1 degree, that is 1 degree 6 minutes, divided by 2 plus C value it is 0.3 they have given into sine of 1 degree 6 minutes. Upon simplification you will get it V1 as 1.081 meter. This is what the vertical component V1. Once you calculated that is a V1, you can observe here, once you calculate that is V1, you can calculate that is the RL of this instrumental axis. By taking the reference of this RL of benchmark, you can calculate RL of this instrumental axis or the line of sight. The formula it is given by, that is given by RL of instrument axis, RL of instrumental axis equals to, you can observe in this figure, RL of instrumental axis I wanted by taking the reference of RL of benchmark. You can observe here. See here, RL of benchmark, plus H1. If you add for this RL of benchmark, you will get RL of this one. I want RL of this line of sight minus of this vertical component, that is V1. That is RL of benchmark plus H1 minus V1. Then you will get it RL of this line of sight. That is RL of instrumental axis. It is given by RL of benchmark plus H1 minus V1. Substitute the value. RL of benchmark it is 418.685 plus H1 is 1.920, minus V1 you have calculated, that is 1.081. Then you will get it RL of instrumental axis as 419.52 meter. This is what RL of instrumental axis. After that, once you calculate that is RL of instrumental axis, you need to calculate that is RL of station B. Now by taking the reference of this RL of instrumental axis, now your aim is to calculate that is RL of B and the distance between A and B. Before going to calculation for RL of B, you need to calculate this vertical component, that is V2. Same as it is, H2 you are knowing. H2 you are knowing. The vertical component V2, that is the same formula. That is same, this V1 formula. Same formula we will be using, that is V2 equal to K into S into sine 2 theta divided by 2 plus C into sine theta. This is what the observation. It is a second observation taken on the staff station B. That is, I will going to give theta to the observations. Okay. Substitute the value 100 into S2 value, it is 0.70 into sine of 2 into 8 degree 24 minutes divided by 2 plus C value is 0.3 multiplied by sine of 8 degree 24 minutes. Okay. Then calculate V2 value. V2 it is given by 10.30 meter. Okay. This is V2. Once you calculated that is V2, okay, you need to calculate that is RL of B station. Okay, RL of B, that will be equal to, observe in this figure, see you calculated RL of instrumental axis, how much? That is 419.52. 419.52 meter. That is RL of this instrumental axis or the line of sight. Okay. Then you need to calculate this RL of B. How are you going to calculate? That is RL of instrumental axis, right? Plus V2 minus H2. Okay, I will repeat it. RL of instrumental axis plus V2 minus H2. Okay, you need to subtract these two. You need to add this V2. From that you need to subtract V2. You will get it RL of this B. Okay, that is what? RL of instrument axis plus V2 minus H2. Substitute the value. RL of instrumental axis is 419.52 plus V2 it is 10.30 minus H2 value it is 2.605. Upon simplification you will get it 427.215 meter. This is what? That is RL of B. Next, last thing what you need to calculate is what? Distance between A and B. Okay. Horizontal distance between A and B. Horizontal distance between A and B when the line of sight it is inclined between A and B is given by, when the line of sight it is inclined, to calculate the horizontal distance from the instrument station to the object, it is given by Ks cos square theta plus C into cos theta. This is the formula. Okay, where S as well as theta, you need to take the observation of second observation which is taken on B station. Okay, because you are calculating the distance between A and B. See here, you are calculating the distance between A and B. What are all the observation taken on B? That we have given it as second observation. That staff intercept as well as theta you need to consider here. Okay, then substitute the value. D equal to K is 100 and S2 value it is 0.70. Okay, into cos square of 8 degree 24 minutes plus C value it is 0.3 into cos of 8 degree 24 minutes. Okay. Next, upon simplification, you will get distance value as 68.80 meter. This is what? The horizontal distance between A and B. Thank you.